I just want to introduce 3 groups that worked really hard this week to get some good improvement activity either started or going. The first group will be the PLC programming for the NTP. The second group, and the second group will be the trades value stream. Lots of good stuff coming from all 3 of these teams. And then Valve PMs for the water distribution. So in that order. So we'll start out with the PLC team.
Okay, I guess start off with introductions. I'm Casey Clark with engineering. I'm the design manager for the NTP project. We got Whitney Rex here with our, I don't even know what the title of your group is now. The programming team. And then Amy Beth as well. So the purpose of this event was for the new treatment plant, we are needing to set new programming standards for both our PLC and HMI for the plant. A lot of that has been driven. Yes? I don't know what those. Oh, yes. PLC is your programmable logic controller. So it's basically the brain behind the plant that is making it do what you want it to do. And then the HMI is your human-machine interface, which is essentially the computer screen that you're seeing that also allows you to make the plant do whatever you want it to do. So HMI is the graphics, PLC is the brains. So, sorry, thanks for asking. This event definitely gets way down into more detail than most people are going to want to hear. So anyways, a lot of this is being driven by, for this plant, we are looking to use a PLC that we haven't typically used throughout our system. And so that, with it came some additional features and advantages that we had the potential to take advantage of, but also meant that our current programming standards didn't necessarily cater towards this new hardware. And so we wanted to come up with some new ways to fully leverage some of the new technology and implement some things that we just haven't had a chance to implement before. So the team here was largely made up of some Denver Water people as well as consultants from the NTP project. So we have, I won't go through all the names, but we essentially have our internal programming team, and then we also had the programming team that we have hired for the project. I think that's going to cover the most for what you guys will care about. I kind of went over a little bit of this, but a little bit of additional insight, some of the other reasons for action in addition to what I've gone over is, we're wanting to take advantage of some high performance HMI, and we'll get into what high performance HMI means. And also wanted to look at how to implement a strategy for handling a massive amount of data. And I would say one of the big emphasis for this is with some of the new hardware and technology that we're looking to implement on the new treatment plant, we have a lot more data to manage than I'd say virtually all of our other plants have, and that becomes kind of the biggest obstacle to tackle is how to organize that information in a way that is usable for plant operators while also not being overwhelming. And so that was what we took a big step towards. So I'll turn it over to Whitney to.
So like Casey was saying, how do we manage all this data? So this is very clear for everyone to understand. Obviously, this is really the biggest portion of what we had to decide is how are we going to manage all this data? How are we going to organize it into these structures that are maintainable and reusable and fit into a standard that not only fit the NTP plant, but we can turn around and implement at our existing facilities and distribution. And so without getting into too much detail, essentially every piece of equipment in the field has, information that we're going to pull out of it. we're going to, we call that kind of the data blob. And so that gets formatted into a structure, and then from that structure, we can put it into organizational units, and then we can totalize that data, we can count that data, we can log that data, and then it also goes into the control strategy, which allows us to actually, turn the filters on, turn the filters off, that sort of thing. So we can go to the next slide. So maybe the easiest thing to directly relate is how is it going to look. This is an existing screen that we have at Moffett for the alum system, and you can see there's the alum storage tanks, the day tank, the feed pumps, some trend information on how the system's performing. And initially when an operator comes into the plant, they may not understand exactly what's the most important thing to look at. Everything on this screen is kind of bright and shiny. There's red and green. Some things are red. We don't necessarily know what's important right away. Well, if we look at something we're doing on the new HMI standard, we want the screens to be very muted. We want things to be fairly bland, unless there's something that needs attention. This tank is low, so the meter on that tank is red. This tank is performing well, so there's nothing to catch your attention. Things that are running normally should just be normal. A pump being on or off is not something that needs to catch your attention. But something that's faulted, if this thing has a fault, it could be yellow. That's important. So that's kind of the driving force behind the visualizations is really to just give you what you need to control the process, but not give you all the data, so you have to be able to decrypt it to control the process. So, I don't know. There's a million ways to look at this, so might be lots of questions.
Well, that's me. So, being as that we are the geeks we are, we had a spreadsheet of 94 things we had to get through to move this programming effort forward for the new plant. So we made 94 major decisions, some of which are on the next 2 pages. And just to geek out on you a little bit, the ones I'm going to point out are no duplicate coils, which is really no duplicate destructive bits, which is very important to programmers, so you know. Very exciting for everyone else. And because I'm on camera, and I have a staff that sometimes like to try new things that aren't necessarily good for programming standards in general, I'm on camera and I'm officially going to say there will be no sequential function chart programming. So, it's official, I have it on record, and those are some of the major decisions we made while we were in this. There's like 94 is way too many to go through, but it was a big deal for us, and it really does help our programming team move forward in a very methodical way. Anyway, so next one. So we came up with a timeline of the things that need to happen between now and the next 12 months. As you can see, there's some events, there's some just to-dos, and there's some projects out there that we still have to pull all this together, but not bad considering we had 94 things that we decided. This is pretty light, so we're pretty happy about that too. And then our insights. You guys can read all these, but I think for having a group of people that are all experts in their field, sit down and come up with, we all have our ways of doing things. There are as many programs out there as there are programmers writing them. And so to have that level of expertise sit in a room and be able to make 94 decisions, it was a good 3 days. It was exhausting 3 days, but it was a very good 3 days. And so I think the main thing is we were able to stay on topic. It's not on there. We actually all kept our sense of humors, which was actually pretty important. We learned to trust each other because we don't really know these programmers that's going to be programming a plant that we're eventually going to be maintaining for the next 20 years. So that was very important. Anyway, you can see them all up there. I think that's all we have. Questions? We can geek out if you want. Go ahead.
So is this an updated version of our existing system, or is this a totally different system?
I don't know if I would say updated. It's different.
It's a different, like Casey was saying, the programmable logic controller, the brains beneath it, it's a different piece of hardware. Each PLC has its pluses and minuses, and we're trying to use the advantages of this particular one. And one of the things that comes with this that we've done through this plant is we're bringing in intelligent devices. Currently, we bring in devices that just have a single level sensor. Well, now the level sensor is going to tell you if I'm healthy, is my power okay, what's my level, is that really a good value? I mean, it comes with all this other data that now we have to suck in, and this platform we've chosen handles all that data better than the current one we have. The current one will handle it with other updates and upgrades, and what we're designing here programming-wise will also handle that, and we'll be able to modify our current existing code in order to handle that as well.
So it does integrate it.
Yeah, I mean, that was one of the things you can't, I mean, the HMI, the software behind the graphical user interface has to be the same. It has to be. I mean, you have to be able to integrate this into the rest of the system. And that was one of the things we all knew was going to happen.
Yeah, I would add to that as well. It was an emphasis of the project to try to fully leverage the equipment we're putting on site as much as possible, while also writing our programming standards universally enough that they could also still be applied to existing hardware in other plants and in other parts of our system. So it is catered to this plant, but we tried to keep in mind that we need to be able to accommodate other systems as well.
Some of you guys got through 94 really important things in a short amount of time. What was it about the process that allowed you guys to do this so effectively? Was it a particular tool or getting the right people there? I think it was having the right people in the room. You know, we had the level of experience between the graphical user interface, even not just using this particular one, but other ones in the past. Whitney and I and Yishin are my other programmer that was in the room, and we have hundreds of years experience between all of us on doing this. So if we were quickly able to recognize what made sense for a standard, you know, we know exactly what we have out in our current standards and how we could backtrack, you know, take this new one and kind of apply it. I mean, they're not easy tasks necessarily, but it's a doable task, right? We weren't looking for a completely different standard. We wanted something that we could move. We kind of want to make it, and we still do, want to make sure that what we do is hardware agnostic. So in, you know, 15 years, if this great PLC comes out there, we can still take our standard and place it over there. And that's one of the goals that we have on this as well.
And having, you know, people like Russ Rothkin and Fred from Golden Automation in the room and bringing in their experience and their programming tools, you know, really gave us a lot. You know, when they walk in and they say, we've got this great thing we've done, and we based that on 400 other projects, and this tool also produces all your documentation along with it, and you can take your existing system and put it into the tool and create code. You know, it makes a lot of the decisions pretty easy.
Yeah.
Amy, or Whitney, you mentioned that we're trying to make the screen bland. So what goes on the screen, is that going to be determined by a critical analysis of what goes on the screen?
So one of the other aspects of high performance HMI programming is, you know, and traditionally we've programmed those screens to show a process. So the one you saw up there was alum. Well, that's one process out of how many on a plant, right? And so in order to bring a plant up, you have to go from screen to screen to screen to screen to screen to get there. And so high performance HMIs is going to be designed around, with the operations staff, tasks that they need. So if they need this 6 things from 3 different screens, you pull that into a single screen so that they can do those tasks and see all the pieces they want to see. So we'll be redesigning. We're not taking the existing screens and just making them bland. We're actually going to go through and develop them by task.
Yeah, like primary coagulation.
Right, so there's all, right,
Just the chemical related to primary coagulation.
Yeah.
right.
I would, I'd add to that, yeah, I'd say most of our screens today are kind of built around, here's what the process looks like, let's get everything on there so we can see everything about a process. This is more of a what tasks does an operator need to do, and let's get those on a screen together. The other thing I'd mention about that too is this was kind of the we're setting the standards or kind of the infrastructure for building all of this. This is not actually deciding this is what you are going to see. Those are kind of what we had laid out in that timeline of how do we, now that we have that infrastructure, how do we move forward with engaging the right people in the organization to start building out what those screens are based on user needs. So.
There's a lot of things to decide, especially like as far as alarming and events are concerned. You know, currently you've got a piece of equipment that won't start, for example. You know, right now in our system, if the pump doesn't start, you generally call someone out to go and look at it to figure out why it won't start. And then that person turns around and calls out maybe an electrician, maybe a mechanic, maybe an instrumentation person, maybe all three of them, because it's very complicated. And so all of a sudden you've engaged 4 or 5 people just to figure out what's wrong with it, not necessarily to even fix it. Whereas this system, you know, the operator could click on the pump, it says, I'm not ready to start. He clicks on that and it says, I'm not ready because there's something wrong in the motor starter. He clicks on the motor starter, it says, there's a thermal overload. Right away he knows, I need to call out an electrician. So the operator, in a way, is the one doing the diagnostics, and then he only calls out one person to the field. So that's just an example of what we could do, but there are some, you know, savings to be had as far as efficiency and time. And then maybe if the electrician knows the nature of the call out, they can also bring along the right tool to fix the job in advance of actually getting there. So a lot of those things that come along for the right, potentially.
Gene, just right, pull that up.
You know how to tell it's an IT project? A lot of TLAs, right? 3-letter acronyms. NTP, HMI, PLC. If they said GUI, graphical user interface, I would add bingo. So, but seriously, this thing could have imploded. This could have imploded because these are the smartest people, probably best programmers around here at all. And I wondered how the first day would went. And they got in the same room and they were on the same path immediately. And I asked Whitney, is this going to transcend other plants? And he already said this is going to go to other plants. And I looked at Amy Beth and I said, when can we start on pump stations? And she gave me a stink eye. But we're going to wait. But seriously, this is going to transcend our data. And the other thing they didn't talk about is they have it categorized where they can really organize it piece by piece because there's so much it's going to be very efficient for the user. So good job to the team. Thanks.
Could I get the trades group up here, please? While the guys are coming up, I just want to make note that Rob Richmeyer is process owner, and Steve Holder acted as team leader during this event. Did a great job.
So, good morning. Thank you, everybody, for coming to the Trades VSA. Not all of our team was able to make it today, but pictured up here is who was involved all week. Tyner Hensel, Mark Kielowitz, Ralph Kokazella, Matt McGavin, Rob Richmeyer, Garth Rigg, Dave Bronchio, myself, Wes Eversole, Sam Nim, Steve Holder, and Josh Krieger from Safety's Not Pictured. Like to thank Jason Tossig from Security who sat in for Josh, Mary and Tom and Gene especially for helping us get through this week. And really want to thank everybody who came out for the voice of the customer. That input really helped us develop what we did this week. The basic reason why for this VSA is that Trades heard enough feedback that the work request process was complicated and chaotic, and Trades discovered that scheduled work was being interrupted by priority 4 or emergency work requests, and these interruptions affected the predictive maintenance and preventative maintenance program from being performed consistently. To explain this further, here's Tyner.
Good morning, Tyner Hensel. What we have is our current state map, and as you can see, it's very chaotic, as Wes said. And a lot of it we found out is due to a lot of things being undefined as far as asset criticality, asset ownership. And through that, basically the team felt as though they weren't getting a lot of the right scope of work handled in the ways that we needed to handle it. And basically causing a lot of problems with our customer from start to finish.
Ralph Cocazella, Electric Shop, or ICE. I'm here to talk about the voice of the customer, and this was huge. The voice of the customer was huge, and I'm going to put some of my personal feelings on this also for somebody who's been here since time. But basically, we came up with some conclusions. Work done in a time and correctly. Specific materials, time and frame. Communicate findings and or root cause analysis. So that really simplifies in 3 simple categories what we did, but it was massive. This was a massive undertaking. You're talking about a division, O&M, that takes care of not just one facility, but we're responsible for all facilities. That's carpentry, that's welding, that's electrical, that's process control. So I've always divided it up in 6 pieces of the pie. Well, we take care of all 6 pieces of the pie. So when Rob, who's had some time here, and Steve Holder, all of us that have been here for a while, when we did the voice of the customer, I was usually I don't get real excited or scared about anything, but when we did the day of the voice of the customer, we had it in this room. So here we prepared ourselves kind of for a lamb blasting, but it was everything but that. So we were able to get all the customers that were represented in certain divisions of the Denver Water Board that day, and I could care less if I ever see another sticky note in my life. So that's one thing I did learn this week. But it was amazing how when we first started that, I know the group that I went with, I'm ready to get in the defensive mode. But that ended in about a minute because it was amazing. And you could see, I mean, this is just a small portion of the voice of the customer. But it was amazing to see how we came together as a group as we went from one division to the next division to the next division. And we found out that basically, and this is just that one day prior to this lean event, it was amazing how by the end of that day, or every group that you were with, is that it wasn't a lamb blasting. It was just, how can we make this better for the Denver Water Board? And that, not that I was looking forward to the VSI, but after that day, I was looking forward to the week that we spent that was brutal. It was brutal, but a lot of good things came out of it, and it started from this voice of the customer. So that's it.
So after the current state mapping exercise that we went through, and after hearing from all the different groups that Trades interacts with, we started with kind of a blank piece of paper, and we went through an exercise where we tried to say, if we could set up this kind of system and structure in the best way for our trades and for our customers, kind of what would that look like? And so we mapped this out, and from feedback that we got at the voice of the customer, we kind of came up with some really important components that we wanted our new process and our new systems to incorporate. And that is a more streamlined process from start to finish, with more efficient handoffs of action and also of information. We wanted to place subject matter experts in the right locations throughout the process so that we can have just a better job plan kind of from the beginning. We also kind of, some of us have mentioned getting the information from our customers from the outset will really help how effective our planning is. And lastly, kind of like Tyner mentioned, we really need to rely on a robust asset management plan to help us be effective moving forward. So
So the next step in this process was what we called a silent fishbone. So we had to categorize all the opportunities and treasures that the customers and we came up with without talking to each other. And there was one person that had a hard time with it, but but we got through it. But like I said, we got through it. We labeled them, and then this is when the real work, in my opinion, began. We started discussing the root causes, the whys. Why were things happening? Why were people feeling this way? And then from that, we were able to establish the 5 REI events that we feel, and there were some Just Do It's that we threw in there as well, that we feel are going to get us to that future state. So.
Keep pushing everybody this way. Come on, crowd, to the center. So once we established those RAEs that we want to tackle and the JDIs, we did an impact difficulty, just really how hard is it or how easy is it, and how much impact will it have on Denver Water going forward. So then we've now set up our calendar of events. We came up with 5 RIEs and I think 13 Just Do It's. Now that 5 RIEs, we foresee a couple of them really morphing into 5 of their own from that. So really our calendar event is laid out, but we foresee ourselves being very busy as the year goes forward.
Before I get to my slides, I've been wanting a VSA for our group for some time, and I've been affiliated with CI for some time. And it still was a rough week because you got people in your sandbox, but you got to learn to just trust all the tools and everything coming at you, because there is light at the end of the tunnel. And so our metrics we came up with, our schedule adherence has been getting hit hard consistently. But with all the new rapid improvement events, our Just Do It's, we're thinking we can raise that to 83%. And our reactive maintenance, as you can see, is very high. We'd like to really change that down. We think we can do the same over the next year to 967 from 1157 with these new tools, and then continue this journey. I learned that T&D was on a 5-year journey already on CI, and we're just starting, so we have a long way to go, but there's lots of improvement. Our communication plan. So our metrics, we have visual management, which Steve and the core team built on our wall and trades. We're going to be looking at that every monthly. We also will be showing our progress of our Just Do It's and keeping people accountable to work on their Just Do It's. And that's on our wall meeting every day, every week. It's starting next Tuesday at 8:30 in trades, if anyone would like to join us. And then finally, our updates to divisions. We're going to be tailoring that communication to divisions and foster customer focus monthly, and we'll report out on the wall as well. So,
as far as insights, I thought the most significant insights that the group presented were those that aligned with the Denver Water values. So ideas like working towards world-class asset management and maintenance, ideas of teamwork, the idea of we're all in to make improvements, and I think that's what helped us get through the week. There were times I think it was a little chaotic and people weren't understanding what the possibilities might be as an outcome, but as we got closer to the end of the week and the picture got a little bit clearer, I think there's a lot of optimism now that we'll be able to move forward and fix some of the things that are an annoyance, things that lead to inefficiencies, and that down the road what we'll get out of it is a much better process with much higher quality results and people that are a lot happier about how it gets done. Many questions for Ralph?
just say that, speaking maybe on behalf of the customer a little bit, and being able to see different parts of the system and some of the work that is done by trades, probably what you heard from the voice of the customer was a lot of respect for the work that you do. It is amazing. And employees, people in the system that I talk to, they'll say, these guys produced this. They designed it, they built it. Here it is, look at this. It works perfectly. It's exactly what we wanted. It's incredible quality. And I just hear that time and time again as I go around and talk to different people. So I just want to reflect that and just express appreciation for the work that you guys do.
And Jim, here again, I've been here 40 years, and the work that's done in the trades, not just the electrical work, but the carpentry work, the metal shop work, the any work that's generated, it's just not basics things that are done on the outside. These are specialty items. So if you guys aren't familiar with the trades and you haven't been down to the trade shop, come down there and see what takes place. Or if you could get to a location to see exactly what's done. I mean, we merged with the process control techs about 2 years ago. And, you know, in my view, I'm thinking, oh, they just do this, they just do that. It's amazing how they keep the quality of water at where it needs to be on a daily basis. So you're invited to come down to the trade shops anytime, or anytime you would like to go with one of the techs, we could arrange that. We'd welcome that. So.
I just want to mirror what everybody said. A big thank you. Two things that I saw there is great. The courage to, you know, trades already does a really good job, but to go look at that input and say, we can do better, that takes a lot of courage, and that's really cool to see. And the teamwork of folks that have been in value streams before the 5-year journey to say, hey, we can do this, we'll help you get through it, that was really cool to watch this week. So nice job. Thanks.
All right, I'll go ahead and invite the Valve PM Process RIE team on up here. And Steve Lovato was the process owner, so I'll have him take the lead.
Good morning. Thanks for being here. So I'm here to talk about the small valve PM program for the distribution system. This is the team here. They're a great team, and I want to thank them for all their hard work. A couple of them didn't make it today, but we have Tom Grable, Mark Winkler, Melissa Farquhar, and Leonard Marquez. I want to give a special thanks for people that helped in this event this week. Brian Good, Joe Duran, Tom Rude, Sam Peggies, Jeff Duran, Anthony Gutierrez, Zeke Hauk, Ernest Herrera, Patty Wells, and Alan Crouch. So why do we do this? To eliminate corrective maintenance, we need to operate these valves. It's a 5-year program. It's a water industry standard to get all these valves exercised. There's approximately 65,000 valves in the distribution system. So we need to develop an efficient way to get all this done. So that's why we're here. So our aim was to develop a program to exercise 14,000 valves, 3,000 hydrants, and incorporate water quality sampling, and to use equipment, personnel, and resources in the most effective, safe, cost-effective manner for Denver Water and its ratepayers. And the scope was to do this for the residential local streets, collector streets, which are more, it kind of breaks off in tiers, and I have it in 4 tiers. That's the second tier. They're busier streets, but they're not major arterial streets like state highways or Sheridan, Colorado Boulevard, things like that. That's going to be actually for another event that's going to be coming up soon. So why is this important? This is a picture of gate valves, and the biggest impact is for our customers. You know, when we go out to operate these valves, we want to make sure they work. We don't want to have to back up on valves, cause more interruption to more customers. We want to eliminate water loss. We want to try to eliminate property damage. And we want to make it safe and easier for our crews out there and for everybody that operates these valves for different things like inspectors, valve operations for construction work, things like that. So it's very important to make sure these valves are working right.
So our current state, before we started the event, this was a pre-event that we mapped out our process and we determined our SPOC by the people that were going to be in the event. And then our current state was a two-man truck. We had one guy that was working the valve while the other guy walked around and popped lids and started the hydrants, which wasn't the safest practice. And then our projected target is to implement all the new safety programs to make sure that our personnel are safe out on the streets and we don't get run over. And why we did that was we set up more cones in the cone area, plus we added a spotter while the other guy went out and popped lids.
Okay, our gap analysis is that we had compiled up all these sticky notes with some barriers, and what we did is we categorized these into IT, planning, standard work, and safety were some of the barriers that we came up with.
So after you categorize everything, sometimes it breaks into more than just 4. So we end up having, 6 up there that we end up writing problem statements on. This is typical standard work for a lean event. So then you take your problem statement, you ask the 5 whys, get down to the root cause. Once you get down to the root cause, then you do the if we then and develop your solution approach. So that's what we came up with on that. And then you start designing your experiments to see if they work.
Throughout our RIE, we took a very hard look at the safety in the current state and in the RIE itself, and we came up with 6 different safety assessments. One of them was doing a safety assessment at the site, tailgate safety meeting, stretching to make sure that they're limber and loose before they start working with some of this equipment, to have a flagger and a spotter at the site when they're working these valves. But one of the most significant finds that we took a look at was the valve lid puller tool that we found that eliminates the need to get down on the ground and have them pull up the lids with those tools, saving their backs, their knees, their legs. And it was more time efficient as well, very quick to do that. So we're going to show you a little video of the lid puller and how efficiently it worked.
So, and I'll just add that it wasn't just the lid puller, and I know we talked a lot about safety, but the other thing was how efficient are we doing this process and how do we choreograph this process so it does reduce the cycle time and it is safer for our employees. So it's both of them. And I sped it up because initially it was 10 minutes, but now it's 2. So you're welcome. So it's pretty cool because they were able to put the machine on and it's twisting and exercising the valve. as they're going around and popping all the other lids, so they're able to do things simultaneously. And it's neat too, you can see in this one here, Scott is spotting Mark, essentially. So he's looking out for traffic, making sure that no trucks are coming, no vehicles in general are coming. There's a question in the back.
How many valves are you running here in this operation?
There's about 3 to 4, yeah.
So do you do all 4 in 10 minutes?
No,
No, they didn't end up doing 4 in 10 minutes. It was, we'll get to that, but they ended up getting in an intersection. They were able to get them done per asset. It was 6.5. So 6.5 minutes.
So getting back to your point on how long does it take to do things? So during the vet, we always do cycle time, and we create bar charts off of going out there and getting the manual cycle time. So that's what we did here. And then we threw in the safety factors as well, and that added into the bar chart. If you look at it, it basically comes down to 64 valves a day by the time we did the available time, getting out to the job site, getting set up. We added, I think it was like 15 minutes to do the safety tailgate meeting and the stretching. I think everybody's familiar with bar charts and takt time. And if not, I can go over that. Demand's real easy. Is how many things you got to get done. Your takt time is how long you got to do it for Denver Water as a whole. So that doesn't decide how many crews you're going to actually have. It just says you got to get one of those assets done for that time period. And then you go out there and do your manual cycle times. Once you do your manuals, then it tells you how long either one group or one individual will take to do that time. And then you take that to see if you can actually hit your demand, whether it takes 2 crews, 1 crew. In this particular case, since we dropped the hydrants, we took the hydrant PMs out of the equation, and then we divided the valves into 4 different sections. That dropped the amount of valves that we have to get done on the smaller streets and the collectors.
So this is just going to help me manage the program. We have 6 different tasks that we do in system quality. This is just one of them. I think the major thing that's going to make this work is to keep these guys not interrupted, where they can start their day, they can finish. When they're getting interrupted by valve operations, dirty water complaints, different flushing tasks that we have, that's slowing down their goals. So this will help me manage the group. I'll be able to get some different times. I'll plot it daily and then have a monthly report too. So that's what this visual board's about. Another thing I want to add is, with the help of Melissa, we're gonna have a visual map of all the routes. It's routed through map pages. We'll have a number of valves per map page. And that'll help me manage how many numbers we need to get. And another thing we're going to do is we're going to try to balance the distribution system out. Instead of just doing one quadrant or one area, we're going to try to balance it everywhere. And that's going to help our maintenance people in T&D, where they're not going to be overwhelmed with all the corrective maintenance issues that we find out here. We'll be able to balance that out too.
Okay, our event metrics. We started out with our safety improvements. We initially started out with 0. Our target was 10. We came up with 6 of them. With our PM valves, we have 1,400 for the year, hydrants 3,000. The initial was 1,800 on valves. We targeted 11,283. During this event, we were able to do 29 as an experiment. So with the productivity, initially it was 2 people, 1 valve was operated. That took a total of 480 seconds. Our target was 25%. We were able to drop that with 2 people, 1 valve, and we were able to achieve that with 390 seconds. We shaved a little bit of time with using that, popping the lids and reducing some of the time. So that was a 19% increase in productivity to start with. And employees trained, we initially don't have any, but our target's going to be 100%. And right now, currently, we're at 70% so far. So.
So our completion plan is with Lenny's experiment, we're going to start on the 10th of July, and that's where we're going to have 2 service workers come help us 1 day a week with valves. Melissa's going to get all the number of valves and map pages done by the end of July. Create the quads is going to be the end of June. Get with CDOT about traffic patterns and volume is Tom and Melissa, and that'll be done at the end of July. Numbers for all the other work that Steve does is in progress, and then the discharge log and the water quality readings is going to be Steve and Todd at the end of June.
So if you look at the lessons learned and the insights, really good group to work with. We didn't have any negative comments whatsoever the whole time. It was everybody just kind of working together. And if you could look at the, some of these here, like, took the initiative, practiced safety, got the job done right. Those are all solid things. Work together as a team, adapt to change. One of the biggest insights I had was working through this process, and this is the second go around for valve PMs. So we did go out and we got cycle times, and and it's changed. We got the machines and all the other stuff in the last few years to help out with this. So we addressed quite a few safety concerns prior to this event. One of the things that was keeping us from hitting the metrics or the demand was the fact that the group that we had kept getting interrupted. So they go do other work. So we wasn't giving them the time to actually get the job done, even though we had how long it took to do everything. When we was going through that, Steve was still kind of not sure I'm going to have enough, be able to keep these guys from getting interrupted. And he realizes he has to. But Lenny stepped up, and so did Joe. They work on the emergency service. They stepped up and they said, hey, you know what? I think we might have a little time with our guys. How about 1 day a week? We kind of come up with that. And then they took that idea and drafted out an experiment down to the detail on who's going to replace these guys if they're, if Mark or Scott call in sick or they're gone for a week or whatever. So they came up with a plan for that. They came up with a plan to what's the best day of the week to pull that from so they can run the truck, where they're going to report out of. They did that all on their own, and with some other folks in the room. That's the outstanding part on it, I think, is because they could have just sat there and said, hey, just going to keep my mouth shut. We got enough work in the world and go on with life. Big shout out to those guys. Thank you. Any questions by anybody?
Quick thing, I think exercising the valves is tremendous. Are you also, as you pick the valves to do, will you prioritize looking at next year's capital plan in terms of which one to exercise? Because we've done vault projects and we find out something's broken, the trees going further out. So I'm hoping we can work with you and get ahead of that so when the contractor mobilizes is ready to roll and we're not paying the wage right now.
So there's a few things that feed into this program. One is the construction projects. That includes T&D pipe projects. And we're also looking at the paving. So they go out there and do Denver paving. So we need to get at least a year out on these. So we're going to need some help on identifying projects and at least a year out. the year out is not so that we can get the valves operated, it's so that we can get the valves fixed before we need them. So those got to go down to the maintenance shops and stuff. So yeah, definitely are. And we're doing that on the large valves as well with Danny. So we should be okay on that.
Just out of curiosity, where do you track valve PM maintenance? Is it Maximo or EMAP, or how do you do that? I just don't know. It's through Maximo.
Yeah.
So you're going to go, Deborah, that from 1,800 a year to almost 12,000 a year, right?
Well, currently, we are at 1,800. Yeah, we just took over this year, and yeah, we have to really get our numbers up. But 12,000 is our goal per year.
So you,
Yeah.
and you're going to do that with existing crews, or you need more crews?
Well,
How are you reconfiguring to,
well,
your time frame for getting there, do you think?
well, that's a good question. So what we're going to do is, with the help of the service department and what we have right now, the available resources in my group, we're going to track all that time and see how we are. If we're not meeting our goals, following all these different metrics, then we'll have to look into other resources from there.
As Tom was alluding to, in previous years, this work was done by a T&D maintenance crew. And similar to what Steve has seen, one of the main reasons why we weren't meeting our targets is because we keep interrupting them, because they have lots of different roles that they provide. So, we did a little reorganization at the end of last year, and we moved this function from a T&D maintenance crew over to system quality. For a couple of different reasons. One is Steve's group was already doing a lot of work on valves, so when a developer needs a valve shut off because they're tying into the main, they would do those shut-outs. And then Steve's group was also does a lot of work with preventative maintenance because they do all the system flushing, and those are all generated in Maximo as PM. So he's got lots of experience managing these big workloads, and the idea was that maybe we move these people over, they can be less interrupted, but clearly there's still some of that going on. So part of the data that we'll collect is how efficient can we get with the resources that we have, and if we can't get all the way to our goal, then what are our options? And we've done anywhere between maybe 30% up to about 70% of our goal in previous years. So we've been up in the maybe 8,000 valve per year, 9,000 valve per year.
And how interrupted everybody gets.
Right. Yeah.
I want to congratulate you guys on being able to balance cycle time, safety, and health. I was struck by the corporation of machines not getting all of the potential long-term effects of exercising, and you just really did a great job balancing all of those.
Thanks. Yeah, I feel really good too after this event. As far as safety, I feel a lot better that's my biggest issue, is that these guys are safe doing the job out there. Yeah. So I feel a lot better about that.
We were setting up and we had a truck run through a stop sign, our residential.
Yeah. I want to thank Chrissy and Drake too. I think I forgot. Thanks for getting us through this week. You guys did a great job.
Thanks. Just another great example of great teamwork. The water distribution folks have been doing this for 5 years, and so they're really good at it. I would say that you guys do CI the same way you install pipe or exercise valves or fix a main break now, and I would go to the report outs, and they were using the tools and being able to just find things and taking it for granted and just to saying we're going to improve it, and it was really cool to watch. So nice job, and I love the fact of helping each other out. Another group saying, hey, we got some resources, we can help you out. That's what it's all about. Really good job. Thanks.
All right, so I'm going to go ahead and close this out. If you guys get a chance, look up Paul Akers. So he has this theory about 2-second lean, right? And this group was a really good example of 2-second lean. So small improvements equate to big efficiency. So something as small as, oh, well, let's just use a little thing to help us open up the valves. Or, well, how about you stand here and spot me while I'm doing this? Because otherwise I'm looking around me making sure I'm cool. Just little improvements that make big efficiencies later on. So if you guys get a chance, look up Paul Akers. Good tool, and have a great weekend.